Good morning to the first dozen of webinars that we are completing here at the EHPA and across Europe with guests today from the heating and from the automotive industry. We have Maik Stephan with us from Volkswagen and Markus Klausner from Viessmann. The reason why we are doing this event today is a bit of a cross-fertilization between industries. We're hearing a lot about sector integration. We have recently read the energy systems integration strategy that is foreseeing 40% of all buildings to be electrified. And if energy efficiency first prevails, then this will mean heat pumps in these 40% of all buildings, and 40%, to remind all of you, means 40% of about 120 million buildings. So we are talking about 48 million heat pumps in the building stock by 2030. At the same time, we are hearing that Mr. Diess, the CEO of Volkswagen, has announced that this big company is moving away from internal combustion engines altogether and plans to have 29 million heat pumps in the car, in the segment of transportation by 2029. Unfortunately, an odd number. But so what we see is that there is maybe Volkswagen, the biggest single heat pump manufacturer in Europe in the very near future, if you consider that many of these electric cars will need the heat pump for battery management and end user comfort. But the real reason, or the starting point of this online seminar today, was a visit of myself in the auto world in Brussels a couple of years ago. And I visited, which I highly advise to you, I visited this impressive hall in the park in Brussels, and you can see a lot of old cars. But what I found most remarkable was the fact that you see something like 200 brands of Brussels automakers that were existing before the First World War. And I checked afterwards, it is actually true that Belgium was the biggest car manufacturing country in the whole world before the First World War, and I guess nobody would have expected that. What I found remarkable about that is that if you think how they made the cars at that time, they were completely bespoke. You would go to your car manufacturer and say, I need a car. And they would say, what do you want? Do you want one with a roof, or do you want an open one? Do you want a roof for yourself? Do you want a roof for the driver too? What type of tires do you want? Do you want a spare tire? And so on and so forth, with lamps. So everything was completely bespoke. And that struck me because today we are discussing the renovation wave. It was announced yesterday. We are discussing that we have to renovate 35-40 million buildings in the next 10 years, starting with the least efficient ones. And if you do that today, if you expose yourself to that experience, you will have to go to an installer. The installer will give you an offer. The installer will offer you what he or she can do. And it's luckily, increasingly often, you also find women installers, so that there is some gender adjustment in that industry too. But you will get a completely bespoke solution, and it will depend on what the installer knows and who he has in his own network. If you get a very efficient one, or if you get a very expensive one, or if you get a very smart one. So this is not standardized yet, and that was where I thought, let's discuss between the car industry that has undergone many rounds of standardization and optimization and economies of scale. And let's see if there is something that the heating sector can learn from the car industry. And maybe even in some future, we will see some CEO of a big heating company express the move away from combustion to complete electrification. Having said that, I would like to introduce briefly our two panelists or speakers, because it's more like picking each other's brains. And I would also encourage the audience to write your questions into the chat box, and then we will discuss them and pick them up in the debate. But we have Markus Klausner, CTO of Viessmann, one of the leading manufacturers of heating equipment, but I may say also one of the leading manufacturers of heat pumps, with quite a strong focus recently on the development of new compact units also for the renovation sector, picking up quite a lot of these things that maybe the automotive sector has gone through. And his sparring partner is Maik Stephan, Executive Director for Corporate Strategy for Volkswagen, and probably one of the people closest to this transition that is happening in a company that has a great history in combustion engines and aims to connect now and to create a great history in battery-powered vehicles. I will not talk much more. We have, I hope, for an interesting discussion. We have agreed that we will first hear from Maik, Stephan about the transition in the car industry, and then the reflections on that will come from Markus, Klausner, and then we open the discussion for all of you. So I'm looking forward to this debate. Maik.
Yeah, thank you very much. Hopefully you can see my presentation right now. Yeah. Yeah, I'm happy that I have the chance to briefly talk to you about the transformation of the whole Volkswagen Group toward electrification and climate neutrality. Yeah, we started our journey in 2015. Yeah, after many discussions about the necessity to do something against the climate change. Yeah, we are all aware of the climate change. And when we went into the details, we found out that 14% of the transport sector let's say the transport sector is responsible for 14% of the global greenhouse gas emissions. And when we went more into the details, we found out, to our surprise, that the Volkswagen Group stands for 1% of the global greenhouse gas emissions with our cars, and we can add another 1% if we include our trucks and buses. So the whole Volkswagen Group is responsible for 2% of the global greenhouse gas emissions. Yeah, so we are significant, and we decided to go into the change to drive the change towards climate neutrality. We started our journey, as I said, in 2015, and so what we did is we completely turned our product strategy into battery electric vehicles. Yeah, we started our platform development very focused for battery electric vehicles. So no hybrid systems, no combined systems. So we fully focused on two pure battery electric vehicle platforms. We started to invest into battery technology development. We have set up let's say competence center for battery technology, battery systems, because this was completely new to us. We had no clue about battery systems and battery technology. Yeah, we adapted our value chain, we adapted our purchasing processes, and we started to turn our factories into factories for pure battery electric vehicles. So the first one was Zwickau, which is now up and running, where we invested more than €1 billion into the transformation from combustion engine vehicles production into battery electric vehicle productions. We changed our sales systems, and also we went into the development of charging infrastructure at our sites, but also in the public. Yeah, in total, we have decided to invest so far 33 billion euros into the transformation, mainly into the development of battery electric vehicles and the transformation of our infrastructure, of our plants. Only Volkswagen Group, and we can add another 15 billion in investment together with our JV partners in China. So this is really a lot of money. So far we have decided to produce 26 million vehicles until 2030. The production portfolio is increasing from year to year. So far we have 75 cars in our portfolio, and until 2025 we are going to install across Europe 36,000 charging poles for the different charging use cases at our dealer sites, at our sales companies, at our production sites, and together with our JV partners at Ionity along all the main highways across Europe. So we are turning the whole group into an electric vehicle development, production and sales company. Production so far is established in Zwickau. The next factories in Emden, Hanover, Dresden will follow soon. The production volume, as I said, is really immense. Only on the one of the platforms, the MEB, we are planning to produce in the year 2025 1.5 million cars annually. These are also for the Volkswagen Group huge numbers. What is very interesting in this transformation is that we can already say today that our first cars, which is now available for sale, the ID.3, is already produced climate neutral. So we have been able to change the whole development process, the value chain, the production system into a climate neutral system. So it's not fully fulfilled, so we have to compensate the last percentages, but it is almost secured, and we can guarantee that we hand over an ID.3, a battery electric vehicle, which is completely CO2 neutral. And all the other cars we will bring onto the streets will be produced CO2 neutral. If the customer then decides to purchase also a green energy contract, then the production of the car will be CO2 neutral, the usage period of the car will be CO2 neutral, and in the near future also the recycling process of the cars will be CO2 neutral. And this is then a very interesting and very promising cycle for our transformation towards climate neutrality. What is very important for us, and we are fully aware that there are different opinions in the market across our competition, but also within the decision makers in the governments. We fully focus on pure battery electric vehicles, battery technology, and nothing else. Yeah, from our point of view, this is the only available technology at the moment that can drive the transformation, that it is available, and that is able for a large-scale production. Therefore, we fully focus on battery electric vehicles, and we make sure that our full product portfolio will be electrified and available to end customers. This is one of our major decisions, that we focus on one technology, that we don't go into different streams, different directions. We fully focus on that one technology. What I also want to share with you is the long planning time we are talking about. So we have committed that the Volkswagen Group will be completely CO2 neutral by the year 2030. So we will follow the Paris Climate Agreement, and as I said, we are committed to fulfill the Paris climate targets. Going backwards, you see the chart. Starting in the year 2050, the Volkswagen Group, all the cars running on the streets across the globe will be CO2 neutral. That means, knowing that the car is in average 10 years on the road, that our last car with a combustion engine will be sold in the year 2040. Selling a last car with a combustion engine in the year 2040 means that somewhere around the year 2032, 33, we will introduce our last car with a combustion engine to a market. Because then it will be 7-8 years in the market, last car to be sold in the year 2040, etc., etc. So now we are in the year 2033, knowing the development times, 3, 4, up to 5 years, yeah, that means somewhere in the year 2027, 28, we will develop our last car with a combustion engine. But what is much more important to know is that we are always using our platforms for 2 generations. Yeah, going back from the year 2040, going back to today, and seeing the development times and the lead times of our platforms. That means that somewhere in the year 2024, 2025, we will start our last development activities for a new platform. And this is in the automotive industry almost tomorrow. Yeah. Having said this, yeah, promising that the Volkswagen Group will be CO2 neutral in the year 2050 means, as a result, that we did all our decisions today, yeah, that we are in the middle of the implementation of all these big changes, and we do the complete change into battery electric vehicles, development, production, selling, etc., within the next 5 years. Yeah, and the final result will be visible in the market in the year 2050. This is really a long-lasting approach, and it means that the complete group will be changed, all the organizations, all the entities, all the brands, and they are all going into one direction, only one direction, and this is battery electric vehicles with this today available technology. Yeah, this as a very short overview of the Volkswagen Group transformation process. Yeah, we are very happy that we have decided to go into this direction. We are fully convinced that this is the right direction, and this is the only way to save our world.
Well, thank you, Mike. This is indeed impressive, and I assume that you can probably write a number of books afterwards about the challenge and how you successfully mastered it, not only for this decision, but also for the way in which you brought along all your employees and all your dealerships. And I think that is probably one of the bigger challenges, to bring all these people that need to help you to sell these products on board for such a change. Maybe we can talk about that at the questions and answer in the discussion afterwards. Because my original idea was that we're just discussing economies of scale and smaller footprints and things like that. But now it seems to me that it occurs to me that actually the heating industry has the same challenge in front of itself and is not as advanced yet, at least not when it comes to very clear decisions. We're still discussing quite in many occasions that we need everything and we need all the solutions. And so that is something that maybe the car industry has undergone a while ago. And you said yourself, not every car manufacturer has taken the same decision. But that is probably the interesting part of this debate, that the heating industry is following maybe with a 10, 15 years delay, but has to change faster now. So Markus, Klausner, how would you reply to this? And maybe you can also outline a little bit how Viessmann sees that, and if you can abstract that a little bit more, what do you think is the really challenge for the whole heating industry?
Thanks a lot, and I'll also try to outline what are our challenges. And to start that, I would like to share some thoughts on what are the common challenges to the heating and the mobility sector. Now, the decarbonization has a direct impact on citizens, and the direct impact is the energy bill, because the energy bill both for heating and for mobility is substantial. And the EU Commission has the clear goal to leave nobody behind in the energy transition, which means that we have to ensure affordability for the energy transition solutions. That's a social responsibility we have, and that's also the basis to ensure that our citizens support the decarbonization project. Now, in my opinion, the technologies for decarbonization, they are available, and the main challenges today are not so much related to finding a solution that fits individual needs, I mean, I don't want to say that there are no such challenges. I mean, if we think about the suitability of heat pumps for buildings with a high heat demand or high heating system temperatures, then we haven't solved that problem yet. Or if I think about the energy density of the batteries, which is far from the physical limits. However, this is not what would cause me sleepless nights. I think the main challenge is related to the energy system transition. And the challenge number one I see in the energy system transition is infrastructure and supply, because we need to optimize the investments for a future-proof transport distribution network. We need to secure the availability of connections of that network to all end users and the availability of decarbonized energy sources. So system choices, they should deliver a decarbonized energy system at the cheapest cost possible. And challenge number two for me is fast progress on the greenhouse gas emission reduction. If you look at the simultaneous decarbonization of heating and transport, that causes quite a challenge for the energy system as a whole, because they both depend on the electricity system and whether the electricity system can cope with that. And we are currently in the middle of a transition from dispatchable coal, natural gas, and nuclear to non-programmable wind and solar. And they have a different geographical distribution. And at the same time, we need a stable and highly reliable electricity supply. And for Germany, we haven't even answered the question what happens to our nuclear waste, because that's at least an issue of the public debate here. So overall, we pretty much depend on policies and regulation for infrastructures, and also actually on natural monopolies in the energy world. Now, the whole discussion about this energy system transition in heating and transport, for me, can be summarized as follows. First, electrification will be the backbone of decarbonization. However, I'm clearly saying electrification alone will not be enough. And what is also interesting, the boundaries between stationary and mobile applications, they become blurry, because when we think about a residential home energy system with a PV system, that PV system can power a heat pump and an electric vehicle. And the question is, what's basically the best decision looking at the low yield you get out of a solar field? So overall, I think buildings and the mobility sectors, they have many challenges in common. And we should tackle them with the following mindset. We should focus on how we can further join efforts to define concepts that accelerate the decarbonization in a socially responsible way, in the context of an electricity sector in transformation, because it's already ongoing. We have to always take a systems perspective beyond sector boundaries. And then for me, one thing is clear: one single infrastructure for one single end-use energy source cannot make it. So, and that relates pretty much to what you said, Mr. Nowak. Why is the heating industry not taking a clear position? It's not because we cannot decide, it's because we are highly convinced that a mix of technology and energy sources is the most cost efficient and resilient. Now let's have a closer look at heating in buildings. A mix of electrification, basically heat pumps and direct electric heating, where heat demand is sufficiently low, and renewable bio-based and power-to-X fuels that power basically combustion heat and also combined heat power units. That ticks the energy system boxes far better than electricity-based heating only. Why is that? Because we have steeply increasing costs for the electricity system in case of an electricity heating only scenario. If you look at this qualitatively, then additional costs versus our heating mix are due to the larger electricity demand over the year, because the required volume of the terawatt hours overall increases. And because of that, the installed capacity of non-programmable renewable generation capacities, we have a larger electricity system peak load, because there's a need for dispatchable capacity, the increase as the fleet of heat pumps and also electric vehicles goes up. And we have to make sure that in that energy system there aren't any blackouts, what we call in Germany the kalte Dunkelflaute. And there has to be a larger dimensioning of the electricity transmission distribution networks, because they have to be over-dimensionized for most of the time to meet these drastically occurring peak loads without any blackout. So now you could say that heat pumps add some flexibility to the electricity system, for example, via thermal storage, but I would say no, let's not mix the resource adequacy over long periods of time and the flexibility over shorter periods, because otherwise we get a confusing discussion. When you add load, you need to make sure that you cover that load in the first place. Another key reason for our argument for a mix is that it's simply better suited to cater different building conditions for different investment capabilities of the households. If you look at a multifamily house, co-owned, today with individual wall-mounted boilers, that is going to be difficult to electrify during renovation. A central heating system requires a revamp of the entire heating system and not water installation. And individual heat pumps on balconies would definitely not be the first choice to go. So what I would like to do is add some numbers from a recently published German Leitstudie from DENA, Integrated Energy Transition, which is in our opinion one of the most thorough system analysis for decarbonization available so far. It clearly comes to the conclusion that for a cost-optimized decarbonization of the heating sector, we still have close to 9.5 million combustion heat generators in 2050, operated, very important, with decarbonized power-to-X fuels. If we compare that to an all-electric scenario where there would be just 1.5 million combustion heat generators, then that all-electric scenario is significantly more expensive, specifically 500 billion euros more expensive than the scenario with the 10 million combustion heat generators based on decarbonized fuels. Now, what are the drivers for that cost peak? It's peak electricity demand in 2050 that would total up to 160 gigawatts. Keep in mind, Germany today has 80 gigawatts versus just 102 gigawatts, which is basically a little bit more than 20% more than what we currently have when we have the 10 million combustion heat generators. The electricity demand for heating would be 280 terawatt hours versus just 240 in the technology mix scenario. And the case almost no combustion relies on envelope renovation rates of 1%. And as you rightly said, yesterday we had this new EU regulation, which clearly calls for higher renovation rate, which would even drive higher electricity demand. Well, so what's the conclusion, basically, from all I've said? The cost-benefit analysis that I just presented duly considers that a heat pump delivers 3 units of heat for 1 unit of electricity. Takes into account that green power-to-X fuels also have to come from abroad, produced from electrolysis driven by dedicated renewable electricity capacities. And what counts overall is the systems view. And the systems view always says, what is the preferred choice in a mix of heating? What does it mean for us as a company, for Viessmann? We clearly say heat pumps will be the backbone of a future decarbonized heating mix. However, they need to be complemented by power-to-X for combustion heating and combined heat and power generation and hybrid heat pumps. There need to be solutions for on-site electricity storage to optimize self-consumption and demand-side response. We need to interact bidirectional in real time with electricity and district energy grids for the integration of renewable energy. That also, by the way, integrates the charging stations that we see emerging in the residential households. And we have to reflect an overall balance of supply and demand, especially accounting for that fast ramp up in e-mobility. And we need to make sure that we utilize digitalization to the largest extent possible to make these decentral energy systems work worthwhile. And I would definitely conclude with the statement, we need to work together to add value for our customers and enable the energy transitions at affordable cost. That would be my statement. Hand it back to you, Mr. Nowak.
I think you gave a lot of food for thought here already, and let me start with a bit of a maybe controversial question, because I assume that the car industry could have said exactly what you just said 10 years ago. We can't have that much electricity. It's going to be expensive. You know, the poor people can't afford the electric cars. This will run into blackouts. In winter times, when the cars is not as efficient, we can't afford that. So apparently, Volkswagen took a different decision. They said, no, the right decision is to electrify fully. And you're saying now, or at least I understand you a little bit in that direction, in order to keep the system stable and balanced, we think that we cannot electrify. But at the same time, the car industry will electrify, automotive will electrify a lot. So how do these two things work together? Is the car industry ignorant to the needs for the stable grid? Maik, Stephan?
We are pretty sure that there's enough energy available. For sure, we need green energy, yeah, and we need the energy at the right time, at the right place. And there are still some challenges to realize that. But energy is not the problem, yeah. As I said, we need green energy. This is a challenge. Yeah, this is much easier in some countries like Norway or even Spain or Iceland. Yeah, this is not as easy in Germany, but we see the transformation, and we are pretty sure that green energy will be available at a certain point of time. And combining the battery electric vehicle with green energy is the only way to go into climate neutral mobility. It is at the end so simple.
Okay. Do you want to react to that, Markus?
Yes. Yes, I would like to, because first of all, I think that the starting points for the two industries are different, because this technology mix scenario, which we basically followed over the past years, has already led to a significant reduction in the carbon intensity of our sector, actually to a much larger degree than any other sector. Because if you look at most industrialized countries, according to the International Energy Association, the carbon intensity of the space heating is now at 65% compared to the value it had in 2000. That's quite a significant progress. And also interestingly, space heating overproportionally contributed to a decarbonization of residential energy use or energy carbon intensity. Is it enough? No, it's definitely not. And I mentioned that we also have that goal to meet that net zero scenario 2050. And today we already have, and that's a significant share, much higher than in transportation sector, 11% renewables overall in the heating sector. And if I look at our company, we are currently, the revenues from renewables are 25% of company revenues. So it's not that, you know, basically we are at the place where we try to keep the fossils. All we said is that transition has to be based on a mix of technologies to make that transition affordable for all end users. And that's why if you say heat pumps are the backbone, they need to be complemented by technologies that are not heat pumps. And to make a case in point, at the moment, as it stands, when you as a residential customer install a heat pump, it's 2.5 times more expensive than a wall-mounted boiler. And if you replace an old oil-fired boiler, that oil-fired boiler emits 350 grams of CO2. All right, and if you replace it with a heat pump, you go down to about 120 grams. If you replace it with a modern condensing wall-mounted boilers, you are at roughly 200 grams CO2. Now, if you look at the CO2 avoidance cost for the customer, the two devices, they behave completely differently, because the CO2 avoidance cost is about 120 euro per kilowatt hour for the boiler, and goes up to almost 200 for the heat pump. So I'm saying is, we should keep this in mind, and we should also keep in mind that the EU has this clear goal of making the energy transition affordable.
Yeah, let me add a few words. Let me add a few words. Of course, our combustion engines are becoming cleaner and cleaner as well. Yeah, and we are working heavily on our technology and development, that our gasoline engines are becoming cleaner, and we are going to 100 grams, 95 grams, etc., etc. But there is a limitation. Yeah, and in order to reach the target of zero, yeah, we have to conduct the full change. Yeah, we cannot rely on a mix, because there is a limitation. Yeah, and if we do not decide to fully go into the electrification, we will never ever reach the zero goal. Yeah, it is a long-lasting approach, and it cannot happen right now, but we have to start, and we have to make it happen over a long time.
Can I offer you a bridge maybe in between these two? Because Maik, Stephan, you said that that Volkswagen is also offering now a green electricity tariff. If we consider that power fuels and biofuels should be part of the solution for heating, is a company like Viessmann prepared to offer certificates of origin for the amount of fuels that you use over the lifetime of a product? So could I buy a new gas boiler or a new hydrogen boiler with 20 years of green hydrogen? in my supply? Would that be a solution for the problem?
It's a possible model, even though we are not currently a gas utility. As you probably know, we offer our customers quite successfully already with our V-Share energy community, the access to green electricity. We did not venture into the gas business so far, but I would like to make you use this argument you just said. If you buy a condensing boiler from us today, we can guarantee you that that boiler already operates with up to 30% hydrogen. And in about 2 years, we can guarantee you that that boiler can be run on 100% hydrogen. All you have to do is to change that the burner, which is a not very expensive component of the boiler. And the 30% hydrogen capability you get essentially for free because it's already part of the electronic combustion control. And I'm not arguing for operating the boiler on carbon-based fuels. I'm saying that let's make sure that whatever we put in today is perfectly suitable for renewable energy sources. And the hydrogen for me is one, and that's probably a big difference. Stationary hydrogen versus hydrogen in transport, I see a huge difference there, because for us, from a cost perspective, it's extremely attractive. For the cars, I would think the business case is a bit different.
Charging is difficult.
I would like to move away a little bit from the hydrogen, because at least from my understanding, we don't have green hydrogen today. So whatever we put in, the brown hydrogen will not make it better. To the contrary, I mean, the capability is good, but maybe you follow me a little bit into the direction of how do we integrate the two systems. And I think that is maybe more interesting. If we need all these heat pumps in the future, and you said yourself, I mean, I think I understand the DENA studie is for Germany, and you said it's a difference between 9.5 million and 1.5 million, so we can discuss market shares. But I think we agree that there's going to be a huge amount of additional heat pumps that we don't have today, and that was the purpose of today's talk. So let's see how we can get them into the market. And do you think that if Volkswagen becomes a huge heat pump manufacturer, and I understand also, and maybe you can say something to that, Mike, because it's a question from the audience, what about which type of refrigerant have you chosen? And I know that there is some CO2 in the game, and we are also discussing HFOs, but could you imagine that Volkswagen sells the heat pumps as an OEM product to solution providers that want to integrate mobility, maybe a battery, photovoltaic, and a small heat pump? I mean, Elon Musk has said something like that in a very 2 minutes of the battery day speech. There was a question on the HVAC system, and Elon Musk has said the HVAC industry is the next one that I need to disrupt. So Markus said it, there's somebody coming for you. But Mike, do you think this is going to be an opportunity?
No, this is a very good question. It could be an opportunity, of course, yeah, but so far I cannot imagine that we are going into this business. Yeah, first of all, we have to make sure that we get the right components in the right quantity and quality for our products. Yeah, and as I said, one of the major points of our strategic development is that we fully focus on what we can. Yeah, and currently we are a producer of cars, and we are going into the more into the mobility sector, into mobility services to offer not only the hardware but the services as well. Yeah, and so far we are not discussing, and I really cannot imagine that we are going into this discussion that we will be becoming, let's say, a sales organization for components. Yeah, most unlikely.
Okay.
This is not our core competence.
I will not ask Markus if Viessmann aims to start to produce cars, but what about the integration? We have one question here that says, where do you see the lead when it comes to controlling the energy demands in a building? And we will see. I think we will see that clearly. We will have charging stations in the home. Viessmann offers this type of the electricity. The car will want electricity, and we want to have a shower at night. So how do you see that, and how much IT development is already ready to connect the two sectors?
This is okay. Please.
No, please.
Okay, this is for sure a very interesting point. Yeah, and we can contribute. Yeah, Now we are selling our cars with a very interesting asset, the battery. Yeah, the cars have a capacity of 40, 50, 80 kilowatt hours. Yeah, and this capacity can be used for a house. Yeah, with bidirectional charging, the household can use the battery, yeah, to get let's say cheap and clean energy out of the car for the usage in the household. Yeah, and this can be combined, should be combined, and we are completely open for corporations here, yeah, to make the best out of the situation. There is the asset of the battery in the car. Yeah, in many cases the car stands close to the house. Yeah, and with the connection with bidirectional charging possibilities, yeah, you can imagine what business opportunities occur here.
I fully agree, because when you look at, we don't sell heat pumps today, and our customers, they are prosumers because they produce electricity, right? I mean, a typical installation today that you see in a modern building, and that's a system that we sell quite often, is a heat pump with a PV and a stationary battery. And the stationary battery in the house is a lot smaller than a traction battery in a vehicle. Typically, the German average battery is between 8 and 12 kilowatt hours. And of course, if you have a charging station connected to that, and the charging station is connected with a home energy management system,
yeah,
even agreed with the automotive industry area in the protocol, because you have a standardized protocol to the charging station where the vehicle can basically request its charging demand, and then e-bus, where at least the VDA agreed that is going to be used to basically feed that information to the energy management system. And then you can use the battery of the vehicle as part of your home energy system. Even the autarky rates go up. Now, when you ask what IT development is necessary, we will launch next year in fall a home energy management system that's actually optimized for mobile storage, actually accounting for these batteries, because they increase the autarky rate for these residential households. So that is an extremely relevant scenario. And when you ask who is in charge of what, the way at least we discussed it in the cooperations with the auto companies is that the electric vehicle comes with a charging demand, and the home energy management system takes care to balance these demands to the best optimized way. And as a customer, you can decide, do I optimize for autarky or do I optimize for fast charging? That's basically the algorithms can do whatever optimization you choose.
Yeah, and not only for private households, but for multi-story apartment buildings, for factories, for companies with car fleets. Yeah, there are many solutions possible.
Yeah.
Well, now we are going into interesting discussion on services, because then the end user will want comfort, as you have said yourself now. So what about heat as a service, mobility as a service, mobility as a service? Where do you see your respective companies and maybe the whole sector moving in that direction?
Maybe I start on this one. We already have heat as a service as a commercial offer. We started that last year. Sorry to correct that, 2 years ago, and it's developing quite nicely. And especially looking at the high cost with these new energy systems, I see this as definitely an emerging business model that has a high relevance for us. And also, when you look at business models that somehow make the or allow the customer to participate in the energy grid, you have more and more decentral generation, and that means basically that there is you have to balance demand and supply. And with all these prosumers and the batteries available, you can basically actively participate in these energy markets. So combine it with the heating as a service, and that makes a affordable business model for the consumer.
Yeah, and of course we also offer mobility as a service. Yeah, we clearly see the trend that not all the customers want to have their own car, but they want to use mobility, and therefore we are going into this business. We have launched our Moja services, ride-hailing services in Hanover and in Hamburg. We have launched our WeShare services in Berlin, for example, where you can have a short-time rental of an electric car. Of course, all these services are fully with battery electric vehicles. We have scooters on the roads in Barcelona and Madrid, etc. We are going into this direction, but we are going carefully into this direction because this is not yet a profitable business. It is a difficult business. and we do it very carefully, but step by step.
I'm getting a few questions here on the recycling aspect of heat or mobility as a service. Then you are in full control of taking the cars back and taking the heating systems back, taking the boilers back. Is that something that is already on your radar? Like, will you have to redesign the products when it comes to the circular economy aspect of providing services instead of products?
Yeah, a very interesting and a very important issue. But unfortunately, we are not in control of the circular economy. We are selling the cars, yeah, and therefore we are not owning the battery, and we cannot easily take back the battery to start the recycling process. Yeah, it is important for us that the industry, the recycling industry, starts to further develop the capacities and the process quality, etc., because it is important to get as much material back out of the used batteries, but it is not in our hands. Yeah, this is important to understand. The battery is, once we sell the car, it is away. Yeah, we would like to use the battery after the usage of the car at the end of the lifetime. Yeah, but it is at the moment not possible. We could buy the battery back. This is a huge investment then. Yeah, we are working on business solutions. We are working on this because we see the necessity to fully recycle the batteries in 10, 15 years down the road.
Yes, how is that for heating?
Well, actually, in a heating as a service scenario, that's a highly relevant question. And yes, we have that on the radar because when you look at the products as they are designed today, you know, they are designed for a guaranteed lifetime of 15 years, but most of them last a lot longer. Typically, they're 20 to 25 years around. Now, in a heating as a service scenario, we basically charge the customer euros per kilowatt hour of heat used. And that enables completely new models for, or basically that enables us to design the product differently. And if you really think about a circular economy, taking the products back because we guarantee availability, you need to design them for automated disassembly, because then you would do that in a factory and not individually. And when we look at the product architecture today, remanufacturing is indeed an option, and we look at that already for the heating as a service scenario. And one thought on the batteries from vehicles. The batteries have a very interesting aging characteristics, and the end-of-life criteria for the automotive batteries when it reaches 80% of its initial capacity. But basically, if you look at the cycle lifetime, the next cycles, they lead just to 10% reduction. So basically, that's exponential degradation, which means that there is really a secondary use options for these vehicle batteries. You could use them as stationary batteries in their second life, because the requirements for energy density in a home are not as high as in a car. In the car, I would always see that I get the best available technology. You could even think about using traction batteries in a second stationary applications, and then you would make the energy system yet more affordable. That's probably something.
We definitely see many options, yeah, for the battery second life activities, yeah, but we have to find out whether it is more feasible to use the battery in a second lifetime or to recycle the battery, yeah, because we need the material back, and the time will show what is most efficient, what is best, what is the best economical way to use the battery in a second life or in a recycled way.
But imagine I buy one of the new ID.3s. Actually, I would like to buy the ID Bus when it's available, like so many other people, I think. And I take one with a 90 kilowatt hours battery, and this 90 kilowatt hours battery comes, and so after I don't know how many years, 6 years or 7 years, this battery is at 80%. So can I get it from my car? Is that easy? And then I go to Viessmann and say, hey, you know, I have this battery now. Can you just integrate that into your controls? Because it's 90 kilowatt hours. 90 kilowatt hours is maybe a week of heating. So then these dark nights when there is no wind, they become completely unscary for me. I can just sit through them because I have my second life battery. I have my new battery in my car, which works in bidirectional charging, so I can even go to 2 weeks.
But you can leave the battery in the car to use it. Yeah, you don't have to take it out. Yeah.
Yeah, but I mean, the car is at 80%, so you would declare it not fit for transport anymore. But then I want this. Do you think it's an opportunity to get the battery out of the car and I don't give it back to you? I want it for myself because I have paid for it already. I buy a new battery, which is much better at that point in time, and I take the old battery, as Markus Klausner said, and then I will put it into my house.
Yeah, as it is your car, you can do whatever you want. Yeah, but it is not easy to get the battery out and to put a new battery in. Yeah, it is not like with your household devices where you can easily change batteries. Yeah, it is completely integrated. It will not be an easy process to change the whole battery and to take it out.
Okay. Okay.
Yeah, we guarantee that you can use the battery over the whole lifetime of the car.
Okay, and the lifetime of the car is?
One remark to that, because in my previous life I was also responsible for automotive electric powertrains. The architecture today wouldn't permit it, because the architecture we use is a series of cells connected. Basically, in the auto batteries, and actually we use the same architecture for stationary batteries. They have a totally different voltage and different power requirement. The power to energy density ratio is different. So if that scenario, what you just outlined, was really a real case, we would need to change the architecture of the battery, which for good reasons today is not changed.
Okay, I rest my case. That's fine. Absolutely fine. We have a few questions here on the refrigerant discussion, and maybe this is something where there is maybe an invisible but a very strong connection, because also in the F-gas phase down debate, the heating industry was quite relying on the change that took place a few years earlier, I would say, in the car industry. So now I hear that that in the ID3 and ID4, the heat pump is a CO2 heat pump that is used for battery management. So you are moving in that direction. Is that a discussion or is that a decision that will also be applied to the other products, the other electric cars? And do you think that will have an impact on CO2 in heatings, maybe, Mr. Klausner? Because in heating, CO2 at the moment is still a solution that is seen as quite complicated. High pressures, stainless steel, high cost. Can we benefit from an advancement in electric vehicles that could help us in the heating system, in the heating industry?
Clear answer, yes. We have to separate basically the CO2 technology and basically the economies of scale, where the auto industry could tremendously help, because today we talk about several 100,000 CO2 heat pumps entirely based in Japan, because in Japan they are used for domestic hot water. And because of the, let's say, limited scale, the components are extremely expensive. Now, if the auto industry moved to CO2-based refrigerant cycles, then we would expect that the key components, especially the compressors, become significantly cheaper, so that would help. The second thing is we need to look at where can we apply CO2 heat pumps. That becomes tricky, because a CO2 heat pump is a suitable technology for domestic hot water applications. And what prevents us today from using it is the extremely high system cost. It's a factor of 2. If you look at the space heating, CO2 would be not a good choice, simply because of the small delta between the ambient temperature, between source and sink. And with a transcritical process, you would need to have an extremely complicated refrigerant cycle in the low COP, so that would not be the way to go. And I don't think you have to do it, because we have with propane and other natural refrigerants that are perfectly suitable and reach extremely high COPs. Now, I know that the problem with propane is it's an A3 refrigerant, so that means it's explosive. But if you clearly say that you have the refrigerant cycle outside your house in an outdoor unit, then there is absolutely no risk with a proper safety concept. So clear statement, there is a move towards natural refrigerant. I see rather propane for space heating. CO2 is an option for domestic hot water. And yes, we would benefit for the domestic hot water application if there's a large number of CO2-based heat pumps in the automotive industry.
And will Volkswagen be the leader of CO2 heat pumps?
I don't know. Honestly, I don't know. I really cannot add value to this discussion. I'm not into these technical details. I don't know. I really don't know.
Okay. Yeah, that's fine. But I mean, currently the ID3 has CO2 technology installed, right, for the battery management, and it seems to work. You're rolling them out, so there.
Yeah, absolutely.
I think I think I heard it's an option because of the high cost, right? You get extra mileage.
It is an option. Yeah, it is an option. It is an option. Yeah. But the take rate is really high.
The first ones, the first has I think they have it all. We will not discuss the details here. That makes no sense. What do we have else? The balancing we have discussed. Here's the question that is interesting, I think, about brands. Andy Bradley says car manufacturers have managed to build strong brands. Why is that not the same for the heating industry? Maybe we don't even agree.
Well, I would actually totally disagree, because brand is actually one of the things we completely build on, and I would definitely say for us that we have a strong brand, at least in our sector. So,
yeah,
I guess the products are not as emotional as cars. Yeah, that's one. But the brands are also strong. This is also my observation, but there's a different emotion behind.
Yeah. You know, the thing is, our products are not visible. They're typically in the heating room or in the basement. And if you don't hear from them, then everything is fine. So that's the big difference. However, also that changes when you think about smart room controls, which now take off significantly in the market. At least you see the brand in the living space, which we haven't before.
Yeah,
that's true. I want to touch upon the transition once more. We briefly looked at this in the beginning, this need to bring your value chain on board. There has been a lot of discussion. Are the Volkswagen dealers, the car dealers, already ready to sell electric vehicles? What did you do to bring them on board, Maik? And I think I would really like to ask the same question afterwards to Markus. Is that a problem that you have, and how do you address it?
Yeah, it's about communication, and again communication. Yeah, taking a decision is easy, but to convince the whole organization that the decision is the right one is really a challenge. Still is a challenge. It was a big challenge, and it took years to convince 680,000 employees plus 500,000 colleagues in the supplier industry, in the dealer organization, and many of them are still not convinced. Yeah, so we are working on that day by day, talking to our people, doing communication on all the challenge, creating transparency, talking about the efficiency of energy, talking about the technology of battery electric vehicles, talking about the positive results, talking about the political situation, that there is a strong target set on CO2 reduction, and we have to fulfill these targets. It's about communication, and it is a never-ending process, and it is one of the most important parts of the transformation.
And you think you have you arrived? Is that solved now?
We are, let's say, on a very good way. Yeah, the first 2-3 years were very difficult, because even our own organization was heavily against this direction. But now, after 4.5-5 years, I would say most of the organization stands behind this direction.
That's good to hear. And then heating, how is that? How is the typical installer perceiving a possible shift from combustion to electric solutions?
Well, actually, they already have. I mean, since the heat pumps have been around for quite some time, the installer does not have per se a problem with heat pumps. It's for them an alternative technology choice that they install besides gas-fired devices. There's one big difference, and that's really a challenge. A heat pump is more difficult to install, significantly more difficult, takes a lot more time to install, and it's a lot more sensitive to the hydraulic installation in a home, the hydraulic scheme it's operating in. And that's why we focus our efforts on making that installation extremely easy to do, even very similar to a gas-fired device, because the gas-fired device is basically mount and forget, because you leave the construction site and it's just working. And even if you made mistakes in the hydraulic scheme, it's not going to fail. However, a heat pump, if you, for example, don't have enough flow, is going to switch off. Then you have to call the service, and it requires a lot of skills on the installer side. And that's why the new heat pumps, we call this fit for intended use. They are designed such that they are basically very similar to the gas devices that the installers are familiar with. And the new heat pump generation we're going to launch next year, they even look like the gas-mounted devices. Basically, for the installer, it looks exactly the same. The indoor unit has exactly the same connections, and it's going to be as robust as a wall-mounted boiler. And we think that is basically the key enabler for the installers to be more open to installing heat pumps instead of gas devices, because that's what you often hear. You know, take the wall-mounted boiler simply because it's more robust, and you're not going to have any trouble. And that's what we have to get away with, because that's one of the key disadvantages of heat pumps.
How is big data helping here, and sensors and integrated interfaces that can also extend to your smartphone, for example?
Oh, significantly, because if you look at the customer journey, right, it starts with planning. Today, there is absolutely no link between what you do in planning, planning that heating system, and then basically commissioning of the system. What we will have in the future is, the solution is already available in the foreign market. We're going to roll it out to Germany next year. That you already do an automated check of your hydraulic scheme at the time of planning. Then you take the parameters from that scheme and transfer it automatically to the heat pump at the installation. And the heat pump itself checks basically whether it's operating in that scheme with a smart sensor actuator test. Now, another option that's going to help us significantly is that is connectivity, because at the moment we have 30% of our 30% connectivity rate for our products. And the data that we get from those connected devices, they are extremely helpful, both for the installer and for us, because we see what's going wrong in the operation, or where the installation can be improved. The key for us is going to be to get these connectivity rates up, and the connected heat pumps also enable us to do remote diagnostics and service. And we see today that the connected heat pumps, they are significantly less expensive in service cost, simply because you don't have to go out there and figure out what's wrong with the device. You can tell this from a distance. And for example, if the installer cannot do it in his B2B platform, he can ask our third level support to do that. And they can also remotely access the heat pump. So that's a lot more efficient than it used to be in the past when they didn't have that opportunity.
Is there sorry.
Last comment. We also gonna next year introduce with the heat pumps what we already have in the market now for 2 years for our wall-mounted boilers and the fuel cells. That is a commissioning by smartphone. That's extremely well received for those installers that use it. But it's basically it's so seamless. You get to the device, it opens a dialogue system, and you can install a heat pump, and you don't need high qualification to do that.
I assume that the same is happening in automotive, Mike. No?
Yeah, digitalization is key. Yeah, first of all, we are saying, yeah, our cars are now a smartphone on wheels. Yeah, they are fully connected, they are fully digitalized, they are connected to the outside world, they are connected to other cars, they are connected to the infrastructure. They will be driving fully automated in the near future. So digitalization is key. But not only the car, the infrastructure, the sales process, everything will become digitalized.
And is there any advantage for big data between the two sectors? Would it help car manufacturers to know the behavior of users, so that you can maybe pre-charge the car or preheat the car, things like that? And would it help the heating industry to know more about the mobility requirements in order to optimize the whole system?
I would not talk about big data here, but for the customer, it makes a lot of sense, yeah, to have connected or to connect the car to the home, yeah, in order to optimize energy usage, what we have discussed, to use the battery to preheat the car before the customer starts. This happens more in a smaller circle, in a smaller environment. But you going here into big data between the two industries, I don't know, sounds big and perhaps a little bit too early.
Case in point, I want to give one example where you really need the data analytics. If you make the charging station in the vehicle part of your home energy system, then the energy management systems work such that they learn the load profile over a longer period of time. So they basically know when does your washing machine go on, when does your heat pump typically go on, what type of heating preferences you have. Now, what would definitely help, what actually the energy management system does is it learns the charging patterns for your car, because after 2 months, you basically know that the person is on Thursday always going longer distances, and then the battery is discharged. I don't know, you need 30 kilowatt hours of charging, while you need on average day 5 or 6. If you optimize the customer's energy bill, you need to analyze these data in order to not run your heat pump and have an empty battery when the car comes on Thursday and basically need high charging, and then you have an extremely expensive energy bill because that charging then comes from the grid.
I fully agree. This is, from my point of view, more small data and not big data. Yeah, because this happens in a small environment. But I fully agree. This is the future. Yeah, and it will become standard.
And data ownership. Can the user own their data, or do you need them to be on your service? And if so, how is that?
The user has to own the data.
Yeah, I think it's legally required.
Oh yeah, okay.
Actually, it's very, you comply with the data regulations, the user agrees which data you use or the installer uses. So that's the way it works. But it's his data. You can anytime, right?
We have a few very technical questions. I think I will not bring them up because they need to be asked to you directly. So what we will do is we will send you the list of questions afterwards. But this idea of connectivity, I think that gets a lot of traction. 36,000 charging stations by Volkswagen. So you will become a major player in also electricity supply. Let's touch upon that again. You said that you're not planning yet to provide green fuels, but what, Markus, what brought you to offer green electricity, and what is limiting you in not providing green fuels at the moment, if that is?
I don't say that we don't do it, but we are not a utility, and that the green electricity was the insight that in order to have a green home energy system, you shouldn't charge it from the German grid, because at the time it was introduced, the average emissions in the German grid were at 550 grams per kilowatt hour. I mean, that's ridiculously high. That's why I'm saying a gas device was even less CO2 emitting. We wanted to enable our customers to join an energy community where you can operate on renewables. And that's basically just a logical extension of the energy system. So with gas, it becomes a lot more complicated. But again, I didn't say no. It's just that it's not on the agenda yet.
The German government will roll out a huge support scheme for charging stations under the condition that you connect them to green electricity. Is that the right way to go?
Absolutely, yes. We fully support this approach. Yeah, absolutely. First of all, thanks a lot to the German government, because this financial support scheme is fantastic. It really helps helps the whole industry to ramp up the volume, to make the change from the combustion engine to a battery electric vehicle much easier. It is the right approach, and to combine it with the usage of green energy is, from our point of view, the right step, 100%.
And should we suggest similar approaches also for heating? If there's also a very generous support scheme for the replacement of oil and even gas boilers with heat pumps in Germany at the moment, you can get up to 45% of your investment paid for by the government, but there's no such requirement. So I can get that money without obliging myself to using green electricity or green fuels for that matter. Is that something that maybe the government should be made aware of, that the same treatment should be given to different sectors?
You are, the data is a clear requirement on the share of renewables, and the subsidy scheme depends on the share of renewables that you use, because you don't get subsidies if you don't use renewables. And I think
not electricity, not the fuel. I mean, of course, the technology itself, yes.
I want to get to that, because what I'm saying is, again, it comes to affordability. Does the customer have access to green fuels and green electricity? And if there is a cost-effective option that would make sense, at the moment I don't see it, because what definitely does not work, if you look at using your PV panel at home to generate the electricity for heating, And that's simply I mean, you get at best, and that's physics, 100 watts per square meters out of a PV panel when the sun is shining, and basically anything less, 200. So it's nonsense. But anyway, there's no way that you could power a completely heat pump with a PV panel. So the question is, where does the green electricity come from? And I think that's why I said energy system transition. That's the big challenge, because our grid in Germany, the CO2 emissions are ridiculously high. I mean, we have now a share of ways above 40% renewables, and yet we are still at 400 grams per kilowatt hour of electricity generated. That means if you charge an electric vehicle from that grid, your CO2 emissions are around 70 grams or 75 grams per kilometer in CO2, and that's not significantly better than a modern internal combustion engine. That's why the key is to make sure in the grid you get the renewables.
Yeah.
But yeah, okay. So then let me close this discussion, because we have 2 minutes left, with an overarching question: CO2 taxation. How do you see that? Is that something that will give guidance to the market, or is that an additional burden that governments should avoid?
From our point of view, we have a very simple answer to this question. We fully support this.
Same for us.
Yeah, it is the right way. It is the right way.
I mean, yeah, same for us. We support that, and the cost should really reflect the external cost that you have with CO2, and then we also support that.
Yep.
All right. Do you have a last statement to the respective other, Maik? What should the heating industry not make? Which mistake you made the heating industry shouldn't copy? And Markus, maybe the same. Do you have any things to share? Where do you think the car industry could learn from heating?
Yeah, as I said in the beginning, the target has to be clear. Yeah, climate neutrality. And then you have to plan the whole process, how to get there. It is about strategic planning and a full focus on the implementation. Yeah, it is not. We have not the time, and we have not the capacity to experience different solutions. Yeah, we have to find out which is the right one, and then we have to go full throttle into this direction.
Thank you.
This is relevant for all industries.
And for us, it's really take the systems perspective and look at the affordability for the consumer, and make sure you follow a decarbonization path that leads to the goal, but is affordable. All
right. We note that down. I think that was very interesting, at least for me. My expectations were fully fulfilled. There's a number of additional technical questions, as I said, that we will not answer today. Thank you very much, Maik and Markus, for your insights and for allowing me to pick your brain a little bit. I think there is some inspiration for many in our audience. For us, allow me to give a small advertising for next week's online seminar. We will talk about renovation of high-rise buildings again. And I think some of the things we discussed today could actually also be useful for that debate, not least the need to have charging stations, so the need to provide more electricity to these high-rise buildings. And if there is enough electricity, maybe we can also put more heat pumps in. Thank you, and have a great day today. And if your fall holidays are coming, enjoy them.
Yeah. Thank you very much.
Thank you.
Bye.
Bye.
Bye.